So here we are different form of instruction. So
can you magnify this? Yeah. So the task is to solve a quadratic equation, right?
Yeah.
Yeah. Do you have the equation given explicitly? So could you first?
The expression is calculate the discriminant.
Can you type the equation on the chat? The structure of equation ax squared, right? Because
yeah.
That's quite important, actually.
Yeah. So x squared to root. So it is this thing. Okay, and after up. So and after it's plus bx plus c.
No. Okay, so retype it equal to 0. It's supposed to be written explicitly.
Oh, yeah. Okay.
And also all x has to be of the same size. Sorry, I'm a little bit pedantic on that, but
no, it's okay. No problem.
Yeah. So that's a quadratic equation, and this equation always can be written. Maybe I will write it in a slightly different way. So we have two possible solutions that are real value and okay, so this equation can be written as, so you see this is in such a way. So x1 and x2 are two possible solutions. So does everybody can see, right? The chat?
Yeah.
So the idea is that so there are two roots of equation, we used to call it like that, and the x1 and x2 can be real value. However, so there can be two different real values. They can be two same real values, or it might happen that x1 and x2 are imaginary values as well. So imaginary values also can happen, and this happen under the circumstance that so-called delta, which you used to have. Delta is delta square is equal to minus something. So this does show that this is imaginary number. It is still possible, but then in such case there are conjugated imaginary numbers, right? Is it clear to everybody what I'm saying, right? So this is theory of polynomials. It's at that stage, it's important to recognize that also the equation of the third order, maybe not everybody knows, of the third order also thus has, so I will write it in that way, b, give me a second, b plus c, cx plus d, this is this equation as the equation as has also three roots solutions. So so the third order polynomial, as mentioned, also has three analytical solutions, but are extremely lengthy. And in high school, we used to learn only quadratic equation, right? This is what we do in high school. Okay, so that's great that you write it, and also maybe it's good if you write the general and the equation form. So this is a kind of postulate that two roots always does exist. There are some central theorems of algebra about that. So you know. Right. Yeah, so you can all right, that's great. All right, so
okay, and after I would just pick that one and write it down. here. So in the flowcharts, we use this form to start a program or stop it. So here we start. We use this form to get inputs or outputs. And here we use it to get inputs A, B, and C, our coefficients. This form, like a rounded rectangle, used to make some calcul.
Yeah, so mathematical operations of any time. So you can say there's a plenty of operations that are built in a processor or a coprocessor, and also functions of that. So this is basically qualifies for all possible mathematical operations that this kind of rectangular shape, like Corandia rectangular shape that's shown, right?
Yeah. And so we calculate the delta, the discriminant, as I write it down. If it's the I miss okay. So I will just make because I found that the discriminant was possible in this application of flowchart making. Just here, you can. It's not. It's a delta here. Discriminant is delta. I will change it. It's like this thing. Oh, excuse me for that.
That's okay. That's okay. Actually, we do have occasion to learn with you. So we see that you are using special web page application.
I use here for flowcharts an application in Google Drive that it's possible to everyone to use, share, and do some graph things. So here, as you can see, you have a flowchart at the left, and explain you what you have to use. Like here is some data, is for display something. So here I use it here to make some start and terminator.
Yeah, but
and many others.
Yeah, but there will be a formal remark. So I fully agree. It's great that you have found such environment, but we used to say that this a rotated rectangular is the second option after. So after start, you have this rotated rectangular. So this is for input outputs. This one.
Yeah.
So
this one. Yeah.
Let us keep everything in convention that if something goes on the screen or on the keyboard, it's output formally. So you don't introduce too many shapes in that sense. So yeah. I will later ask you to remodify this because otherwise we start to be a little bit chaotic, in our way of approaching, right?
Is this one?
No, that's okay. The second one is okay. What I'm saying is a very last one, display. At the bottom, display should be the same as the second one. We need to because of course this is maybe Google convention, but still literature about flowchart is not fully specifying so many distinctions. You know what I mean?
Yeah.
It's just category for input output. But maybe later you can remodify just to show us first what we have.
No problem. So just so that the discriminant here is the same that here. So if the discriminant is upper to 0, if it's true, they calculate the root 1, the root 2, and display that the roots are real and different. Display each root and stop. If the discriminant was less than 0, so it came to false. And if it is equal to 0, yes, so we calculate the only root. Root 1 equal to root 2, and we say that the roots are real and equal, and so we display it. And if the discriminant is not equal to 0 either, we calculate the root. Oh, here is not true. Oh, my bad.
You see. I mean, formally, the real value roots does not exist, right?
Yeah.
Yeah. So also you can you can place this delta stuff because you have discriminant. You are start to remodify some sections, right? So yeah, this is this delta. I highly appreciate it because if we see how things are done in real time, you know, then
Yeah.
we know what's going on. I have always this problem with lectures that if I don't write it down, scratch basically. Maybe you can write the delta is discriminant. I don't know, or you can
yeah, yeah. I will change this, but I don't arrive to put the right code in LaTeX because you use LaTeX to format.
I know.
Mathematical.
LaTeX is / delta, small delta. You write it this discriminant. Okay. I used to use LaTeX very often, you know, because
yeah, it's good. I found how to solve it. Okay, perfect. But it's kind of weird. I will oh yeah, I can do this. Perfect. And so here I can do this, and it's more better like this. Perfect.
Yeah.
So as here the root or calcul, we calculate the imaginate one. We say that the root are imaginary. We display real plus the imaginary e, and same for the negative one. And after we stop it.
So I have formal requests. So whenever you say display, change it to this, or you know, this the shapes, just to keep one convention. And so that's one thing.
Okay, perfect.
So you see, any formal procedure can be represented by flowchart, right?
Yeah.
When you go to board a flight from one country, you know, you have a flight, you go to the airport. All the procedures that you go through can be formally also represented by flowchart, right? I think that's quite obvious, right? Right?
Yeah.
Also, later we are going to define some new classes, like, you know, to consider mathematical structures like complex numbers or quaternions, and to define the operations. So we can also do this on this flowchart formally, right? So so this flowchart is very general. It's just describes the algorithm, right? Atomizes the algorithm into small steps, right?
Yeah.
That are done. And yeah, you have very few things to redo. And also yeah, and now maybe a small discussion about you are going to finish this quite soon. So I mean, you have input output operations that are quite simple here, right? So this you know, this figure this is for input output, right? So that's so putting certain things on the keyboard or reading from a file is an input operation in a sense for a program, and writing to a file or writing to the keyboards, writing to the screen, is output operation, right? That's quite obvious. And then maybe now some formal, and now please tell us how we are going to represent this. Okay, so let us move back to the very start, right? So the start is simply, this is the beginning of a program, right?
Yeah.
This will be everything after main. This will be a start, right? Main procedure.
So, yeah, I have right.
But before moving, no. First, ideologically, ideologically.
Yeah.
Please describe how things are going. So go to the first.
Oh yeah. Okay. So this is the main.
No,
We
but
use.
you truncated something. Can I see the version from before? The before we have seen now it's I don't know the top of this the top of this screen is not visible to us. The start.
Oh yeah. Okay. I see.
Uh,
This is because my.
yeah. I imagine it.
Maybe. This is okay.
Yeah. So it's okay. So this is now when you have a computer program, the beginning of programs at start, right?
Yeah, it's like our main.
Yeah. Then we ask the read coefficients. So we need to write down the coefficients in a file, right? Or we need to type it on the screen, on the keyboard, right? By the keyboard,
we
right?
need to type it in the keyboard.
Yeah, sure. And then
after we make a if.
And then no. Wait a second. And now
we will calculate
this one. So this is a function. So this square is a mathematical operation. So this is certain input that is real value. So A, B, C are on the input, right? In the square.
Yeah.
And the output is delta, right? It's also real value. So this is a function. Formally, this rectangular, just show it to us. Just this, yeah. This is formally. Can you show it by the mouse? This delta, yeah. So this is formally a function, right? Function with 3 inputs, A, B, C, like real values, and one output, which is delta, real value, right? This is a function, right?
Yeah.
Then you go by this arrow. Then you have condition, which is a if, right?
Yeah.
Right. This is if or case. You can say the logical condition,
yeah.
right? This is logical condition, and so all these shapes. How you formally call it in English? I do forget it, but anyway. So this
is
diamond. Let's say diamond. Let's say diamond. So all these diamonds or conditional logic formal conditions. So this is if or case. We can represent it, right? So here and here, and everything else is a function, and so rectangulars are a function simply, right? So a function that has one real value or 3 real values and one real output, right? That's quite easy to do, right? And then input output operations. This one, of course, it can be also a function. It can be a function, right? So that has gives something on the output, and then we arrive to very last of the program, and then we have a return void or return 0, right? At the very end.
Yeah, here, for the stop.
All right. So this is ideologically how the program looks like. And of course, it doesn't have to be a C++ or C. It can be any other language, right? Like Pascal.
Yeah, of course.
But of course, we are concentrated on C++ and C, right? So let us move on with that, right? Okay, go ahead. So first, maybe you are using libraries, and maybe it deserves some description. So go ahead. So this is input output stream, right?
Yeah.
And CMath, right?
It's for using sqrt function.
Yeah.
But
then you have using namespace, standard namespace, std. I have not discussed this yet. Maybe I will discuss next week in more detail. That's standard. So 3 lines are a kind of standard. Then there's integer main. Yeah, this is a standard one, and this is integer main.
With our return 0 to say it's everything goes fine.
Yeah, but formally also it could be instead of int main, it could be void main, right?
Yeah, void main. Yeah,
it's possible, but we are using int. Let's say that's our convention. Yeah, and then there's
so we initialize.
Yeah, there's a float values. So float means real value, right?
Yeah, numbers with the comma.
Yeah. So first question which arises: what's the difference between float and double? I mean, last time we have used double or float. So any formal, so both stands for real values, right?
Yeah.
What's the formal difference between them?
I think that it's maybe an encoding difference or allocated memory.
Yeah. So maybe somebody. Yeah. So the size of float is 4 bytes, and the size of double is 8 bytes.
Yeah.
And the precision in the case of float is 7 decimal digits precision in the case of float, and in case of double, in general, 15 decimal digits precision. So in a sense, float takes less size because it takes 4 bytes. So you have used a little bit, but that's still okay. It's just to know what's going on, right? You know, just to see. Maybe I can. I will send you the link on the chat. So yeah, so you will. Yeah, so you have it also described. Okay, so please go ahead, go back to the description of things, right?
Yeah.
So we have declared. For maybe this line for A, B, C, x1, x2, discriminant, real part, imaginary part. So we have declared 1, 2, 3, 4, 5, 6, 7, 8.
7, 8. Yeah.
8 variables, but we have not. We have told the compiler and to that 8 variables will be used, and each of them will have the certain size. As I mentioned, they will have a 4 byte size, right? But we have not set it values, so we can probably presume this is about compiler default options that they have more or less 0 value initially, right? That's most likely that some compilers will set it like that, right?
Yeah.
All right, and then go ahead. So next line is
Cout. So we write on the screen enter coefficient A, B, C.
Yeah.
After we we ask the user to write A, to write B and C. And so after we calculate the discriminants with the function as you said before. And this is the if, else from here, if, else. So here we calculate root 1, root 2. We print it like root are real and different. We print the count, the value, and an end line here also. Same for root 2. If the discriminant is by 0, we write on the screen that root are real and same. We just calculate the same root. We say then we print that root 1 is equal to root 2 and is equal to x1 and n line. Or this is an imaginary. So we calculate the real part, the imaginary part, and we display root are complex and different, and the root 1 plus the real part. Root 1 equal real part plus imaginary part I, and root 2 is equal to real part minus imaginary part I, and after it stop and return 0.
Yeah. Right. So we see that we have not used functions explicitly, but we have somehow we have also made all the parts of the flowchart, right? So yeah. Right. So are there any questions? So I will pre-assume that let's say everybody among us is able to write down a simple code and remember it, let's say, in your memory, right? So you can write the code that solves linear equation, for example, right? I mean, such thing you should be able to be sufficiently proficient in usage of commands to, to write a simple program, right?
Yeah.
In your mind, right? All right. So, is there anything, any comment to this problem which I have described? So we have not yet arrived to, let's say, classes and data structures, but probably some of you did already have some classes and data structures. At least you might have insight. So next, in a couple of weeks, we are going to implement the class for operations on complex numbers. That's something like that. The complex numbers. So one thing. And second thing is the implementation of the class that implements operations on quaternions. Quaternions. Quaternions are extension of a complex numbers. Quaternions are having three imaginary units. Quaternions. Maybe I will. So this is in a way broader concept of. So you need to think how to implement it. You can implement it by matrices as well. So maybe I will. Yeah, I will give you a link to quaternions. Give me a second. Yeah, of course. The link is all on chat I placed, right? Yeah, so that's our way of doing things. Maybe at this stage, I will also ask the question, which computer environments are you using right now? So to implement your code. So does anybody is using dev C++? Yeah. So I may
I
ask.
don't know.
Okay, so which languages are you using right now for coding?
C++.
Yeah, no. I mean, not a language. How you compile it? How you compile it?
With VS Code.
Yeah. So you the Alan has used Microsoft Visual Studio, right? This is your way.
Visual Studio Code.
Okay, so maybe everybody on the chat is writing down which environment he is using, right? Just to let me know that who is using what. Okay. All right, and then because we can, yeah. Okay. All right, so now probably it's a good time to start this. Yeah, so you see, yes, I see various answers. VS Code, Visual Code, the Visual Studio. So Visual Studio is dominant, I see. Dev C++, Visual Studio Client. So one person is Emma is using Linux, right? Yeah.
Yes.
And two person are using. What is client? Can anybody bring this description to us in a greater detail? Okay. Okay, anyway, yeah. All right. So now probably it's a good time to start this lecture. I just need to. Okay, now it's time for me to share. Yeah, can you see my screen?
Yes.
Yes.
All right.
Yeah.
So that's. So we are going to continue, and our continuation will be by small steps. So it's a little bit extremely big task to give a lecture on C++ because it was a dominant language for more than 20 years worldwide. So it is tremendously well developed, and so we are going to cover conceptually only a small part of that. So today I'm going to talk a little bit about pointers in C and C++, about data structures, about variable types, about operators, about writing and reading and writing to file, about mathematical operation, and about class example. So let's say some of that has been already exploited by one of our colleagues that has presented these things today. This mathematical operation library has been shown. All right, so basically that's about addressing variable. So let's say maybe I will shift the concept. So usually when you set the variable, okay, the variable is set and it might has very different size. So variable can be integer value of integer number that can take 1, 2, 3, or 4 bytes. But variable also can be a picture, two-dimensional picture that was made from your photo of something that can take 20 megabytes of data. And sometimes instead of placement all these matrix elements that represents picture, it's better to point the address of this variable. That's sometimes quicker. So you can address not only variable value, but you can address its address in the memory. And then you arrive to the concept of a pointer. So you have essentially int, you have shown here integer n is set to 4, then so you declared integer value n, and then immediately you set it to 4. Then you have a declared real value of pi and set it to 3.14, etc. And then at the next line, what you did is you declared the pointer value. So pointer was, so this is a pointer, so it's like variable to another variable, and this is so variable that points the address of another variable. And then you do it. So if this variable pointing address to another variable is if this another variable is integer, then you place integer space. You have this this sign, as you can see probably, the cursor line, and pn stands for new name of new variable, and you can set it value. So it's equal, and there's ampersand and name of variable to which it will point. So it will point to integer variable and to this n integer, right? Is this clear what I have just mentioned? Hello?
Yes, it's clear.
So of course, instead of int, you can have you can have any type. You can point any type, and the type structure could be different. So it can be complex value type if you define such type or use certain library, or it can be octonion type. octonion is a number with so it's like complex number with one real value and 7 imaginary values. Let's say this is octonion, right? So you can also point to octonion or to a bigger value. And what does it says is so it's you cannot. So this is about addressing variables and usage of pointers. You cannot address expression unless result is a variable. You cannot address register variables. Registers, the variables that are in registers. So you can include the chunk of the assembler code in your C++ language. Yeah, you cannot, and then you cannot address constants, literals, preprocessor defines. I will mention about this in greater detail later. Okay, and then we come to a idea of data structuring. So, so of course, if we have we can introduce the more abstract object as product in a shop. So every product has its weight and price, let's say, right? A weight could be somehow approximated to kilograms, in the range of kilograms. And price is a real value, let's say a real positive value, not negative. It depends on the economic concept, right? So this is like structure. And then you can, so this is definition of a product type. But of course, in the same fashion, you can define a complex value. You can have two double values, real value and imaginary value, right? And then once this is defined, then you can have a product apple. So you declare there will be one type of products that are apples, and then another type of products that are banana and melon. So this is declaration of existence of those variables of type product of a new data structure type. This is like data structure, right? And then there is a small slide on how things are done. So we're using 3 types of libraries, then using namespace, and then there is movies data structure. Then there is a string title and year. Can you see my okay, my cursor of a mouse? Can you see this?
Yeah, we can see.
Okay. We can see.
So this is for data structures, and then I'm moving. I'm using the option of printing this data on the screen. That there's a procedure or function with void output, right? So this is what I'm declaring, that this is here. I'm just declaring that such functions does exist, right? You see, this is declaration, right? Hello. So this will have input, input movies. It will have input movies, underlined movie. This will be input, and output is simply nothing. It's a void. So and just to, and then this. So you see this procedure or this function with return void is really defined after the main program. So it's defined here. So again, so movies is a variable input type, right? This is variable input type, and then we have C output, and then C output is so it does project C output on the screen. This is movie title, and in next line does project movie year, right? You see those two values, and once it's finished, then you know, there's no return option here, right? You see. So this is this one, and then there is a main part. Sorry for that. I have to. It's a little bit condensed. Yeah. So there is the main part of the program. So standard input main. So you see, we have it like that, and then there is a string type. So the array of the, you can say, of ASCII code from this is a string. This is this variable, and then this is just, this will refer to a title, right? And then I'm having this title placed, mine dot title. Then this is declared title 2001 as space Odyssey, and then there is a mine dot year. This is a number, integer number, right? Here is integer number, right? It could be negative. It depends on the 0 year, where we scale it. So there's 1968, right? And then it's written that on the screen there will be see output, enter title. And now I will exercise with you another thing. This is a Getline. So this is Getline is going to collect line by line as input. So this is like a little bit input in a slightly different version, because this will refer to a C. So this is, so those guys they come from C++ and Getline. You see, all the C code is executable in also the compiler. If compiler does compile C++ language, also incorporates C. So this is another way of getting input, Getline. So this is it gets your title input as a, you know, and then C output, and again Getline. So it takes input like here, and then there is a string stream. This is yeah. So strings. So we have another option of. So we have a string stream, and then so it does project yours. This is also, you see, this is also command string stream. This is also a command from C++. So this is projecting years dot year. So this is integer and my favorite move. And then there is also now we are using the command print, the procedure or a function print movie. That's, as you can see, and we are using. So we are using in a double way. So anyway, is this example is it understandable what I just mentioned? Hello?
Yeah, but kind of hard to read.
Yeah.
The indentation.
Yeah, I need to rewrite the slides. I will send it later once I slightly reorganize them. But the problem is that C++ is C input output are a little bit. I would say that's a little bit another word. There's a lot of alternatives how to place the data on the input and output in C++, and also in C. You will see just in a minute, right? Anyway, we are using library string and SS stream. This is for streaming, you know, string streaming. This is right. This is at very top of. You see this guy, right? All right. So let me move on. Now, just referring a little bit to already. Okay, we have basic variable types and we have extended variables types. So of course, basic variable types is logical variables. This is bool. This stands for boolean, right? So this is true or false. Okay, this is true or false. That's what you know. There now the next type is char. So this is, let's say, if you press the button and place the letter on the keyboard, this is one letter. It stands for char, right? Array of chars stands for string, right? So a word stands for string, or a sentence can stand for a string. Then there is integer value. So you might have a integer, which means like -10, +10, and an integer value like 0 as well. And then there is other options for a float and double. So there are options how to represent real values, and single precision floating point value, this is float, and double is for more exact computations. And there is void, which stands for absence of type, right? All right, I think this is a bit common known, and yeah. All right, let me move on. So now there are C assignment operators, which you probably have heard on that, but I'm just formalizing your knowledge. So in a sense, I would do such steps steadily. So we are going to approach more abstract structure of language from more fundamental part. So equal is just equal. So example, equal to B. Yeah, so this is what you have. So there is plus equal stands is this like if you have a loop, for example, for loop. If next A is A plus B, you can write it in such short way, right? That's just to let you know. In a quite analogical way, if you write minus equal, this will stand this. Oh no, sorry. This is going to stand for like that. A minus equal B, and this is A equal A minus B. Let's say this is this is. So you can use both ways. You can write in such a way in a for loop or in such a way, but this one is shorter. It's kind of commonly used, right? Then you have star equal. So it's basically it's represented like this, and then this is nothing else as A equal A times B, right? Yeah, if you try to put the powers of some geometrical other series, something like that, then there is division equal. It's also written like here, and this is equal like here, right? And then there is operation. Yeah. So does anybody know what does it mean? This is division, right?
For modulo.
Modulo.
Right. Modulo, right? So if I what is modulo 3 modulo 1? How much is if 3 modulo 2? How much is 3 modulo 2?
1.
Yeah. So that's just
give it the rest of the Euclidean division.
So this is because 1 times 2 plus 1 is 3, right? So there's a remaining part after division by 2, right? This is modulo, right? I'm trying to be sure that you know what's. Yeah, that was this. So obviously you see there's these things from one point of view. These assignment operators are something nice, but also so they make the code to be short. But there is obviously also sometimes you can recognize them as a little bit more involving in a sense of so not always what everything is short is so clearly visible in a way, right? Depends on the proficiency of language use. All right, now again another issue is a writing to a file. I try to think in a paradigm of first computer languages. So essentially the computer was invented to compute the trajectories of rockets, missiles. So there was a very pragmatic task. We have certain equations which we know from physics, like differential equations or integral differential equations. We want to encode them in a program. We want the program to give us predictions. So initially, so the ontology of a computer science, contrary to current state of knowledge, was very pragmatic. And just to let you know, the first computers were not actually electrical; they were mechanical. You can it's a very interesting example. You can simply trace the mechanical computer action of mechanical integrator, for example. So if you have the battleships before Second World War, they could measure the wind and various things. And actually, there was a mechanism. There was a mechanical computer, kind of small computer constructed inside, so it could detect. It can combine a few factors, that's wind speed, as so on. So the cannons were moved to a degree that they were able to fire to the target. So this was actually the unknown example of first mechanical computers that were absolutely in use. And of course, there was some other Greek examples from before. So this, just to let you know. So I'm thinking in this philosophy. So I would try to find some mathematical problem to be solved, like to integrate some function or to find square roots of some polynomial and things like that, and then use this computer power to for example find numerical solutions. So because of that, I need to have input-output operations, and then I have to use input-output stream as it is, right? And then I have to open. Then I have to define the file stream, right? That's what's pretty clear here. I'm not touching this issue of namespace. This is using namespace std as standard, right? I will mention. I will point to this section later, and then it's then simply as it is integer main. So that's a part of the main function or main procedure. And that returns 0. That's standard, as we can see, right? And later what we have is declaration of stream. So stream for writing to a file. So my file is a particular stream. And first we need to open the stream, or let's say initialize it in a way, right? So that we associate a name example. So there's some default place in our catalogs, in our folders, let's say. And then we are going to write a text, my file, writing this to a file. This is a text we write to this file. And then we close the stream. So it's very important that when we open, we associate the stream to a concrete position on our disk, and we close it. It's very important to close the stream. So because otherwise various errors may take place. So the result of this operation that is being shown is nothing else as writing this to a file. So file with example name shall have a text writing this to a file, right? That's the result of this action. All right, then there is another way of using this input-output operations and string. I have mentioned to you a little bit before So instead of using char character, you can use a string, which is array of chars somehow. And there are other operations on a string as concatenation of or joining two strings, right? That's other operations. So we have the standard main function as it is given here, and which is given here, right? And then of course we declare a string. Is it as it here? All right, and we get line of text, and then so this projects what's written on the keyboard to see. This is a cin. This is input to a string, right? So it's presumed here that we type a sentence which can be seen as a string variable, and then later the computer does project this this sentence on the screen. This is the output, so it throws the string on the screen. So then there is another text as written here. Yeah, and then we are ignoring input string and the program is finished, right? That's something like that. So this pressing any button can be also represented as cin.ignore with empty brackets, right? All right, so let me move on. Yeah, so basically now there will be tons of possible combinations, and things becomes very kind of so we have a stream class to write on files. This is off stream, right? Then there is a stream class to read from files. This is ef stream, as you see, and then there's f stream that does both, stream class to both read and write from two files. So you can do both using f stream. All right, so off stream is only reserved for writing, and if stream is reserved for reading. And then there's option how to read a file. As I mentioned before, f stream is can be used, for example. So we are going to declare input output stream, f stream, and then string, standard using a namespace std. Again, we have this main part of this program, and then we have a string line which is declared here, and then it's associated, the name file is associated with if stream, and this is given here. And then if there is this conditional loop, so yeah, if my file is open, yeah, then then I'm going to read line by line. So I run over all possibilities of reading, and then okay, so this is why. Okay, one second. So so maybe in the I will first discuss this one. So this is, I'm going to get line by line. I am going to project line by line steadily, and project what I read from a file to a line string, right? Can you see this? Hello? Getline. Hello? Can you?
Yeah.
So this is what. So this is done until there is other. So it's important that. So this one, say. So this is one here, right? And another is here. So when I go to very end, I cannot get it. So if I'm at the last line and I go to the next one, then there will be false, no new line, right? If I'm at the end of file, you understand? I go step by step, right? So I have, I go to very end, and then if this while gives me zero, then I cannot do anything else. So I cannot execute it further. So there's a state of openness. So there is a state of openness, and one is done. My file, so my stream is closed. So I set my stream. I close my stream, and if I were not able, or I was not successfully to open a stream, in a sense that my file open was not valid, then because this was like activation the stream, so that's why I have else cout unable to open a file, right? So is this what I'm presenting a kind of intuitive to you? Hello? Hello?
Yes.
That's fine.
Of course, you need to study Getline syntax, right? Getline, right? You need to study this syntax of Getline and syntax of if stream, right? In greater detail, right? I'm showing you this very simple kind of like simple procedure, just to write a code, because to type things by keyboard is not necessarily a good idea. So I'm not sure if you have ever been able to use C++ for simulation of some physical problems in physics, for example, or in electrical engineering. So you can do it. There's GSL, for example, nice library, GSL. You can try to install GSL on your computers, and then we can run on some examples in GSL. So we can solve some problems. Anyway, no matter what type of problem is, you can have a problem, you can write a program that reads, instead of keyboard, it reads from input file, right? You put the parameters in the input file, and when it is under execution, this program, when finished, it gives you output file, right? So that's what you need to do. That's why I'm paying some attention for reading a text file. Of course, I assure you there are more than 100 possibilities of reading a file in C++. That's one of that, which I'm just explaining to you. All right, let me move on. There is opening a file, and you see, now we are coming to another problem. Problem, let's say. Of course, we used to work with text files. Text files you can edit, you can open in any type of editor, and you see the text value of variables. But of course, it's not. Imagine that you open the image from your camera, you make a mobile picture that takes, let's say, 30 megabytes, very good camera in your mobile, and then what? You are going to place millions, 3 millions by 3. So let's say 5 times 5,000, let's say 5,000 pixels by 5,000 pixels. So this is 25 million. Yeah, so let's say we are going to have a matrix 25,000 in in column and row, such square matrix, and then you are going to have in text file. It's not fully convenient way of data representation. And of course, so there is, you can design a structure, a binary representation, which is more effective and quicker. So you need to be able to open various types of files and data. And this is, this is, so there's a procedure of opening a file, as you can see, and there is a file name and mode. Maybe I will mention, maybe I will point your attention to the very bottom of this slide. You have my file.open, then there is example. So let me place your attention here. Yeah, so this is stream, so my file stream, which I have defined, and then there's my file.open. So there's example.bin. This is name of file. As you can see, right? This is name of file. And then we have this section. So EOS output, open for output operations. So this stands such, so, and then EOS APP, this stands for all output. So this is this one, right? So, okay, all output operations are performed at the end of the file, appending the content to the current of file, right? Yeah, and then there's a binary open in a binary mode. So here is like OR, logical OR. This stands for logical OR. So you want to have these options available at the same time. So you have 3 of these options are activated. So this is, as you see, this operator OR is given here. Yeah, so this is opening a file, right? And with usage of stream. So just to, of stream is stream class to write. Yeah, so that's how it is. All right, then there is also option, as you can see here, and about the maybe okay, maybe whatever you are using, O stream, E stream, and F stream, there is certain default mode that is turned on. So in case of off stream is input. So there is this output, right? So this is this one. So open for output operations. If stream is open for input operations, and F stream is for input and output as well. So you see, this is what is given here. Yeah. So so this is again, you can place it as here. So there's a file associated and mode. Yeah, this is a bit technical. So actually we are using certain classes, and I'm going to approach to the classes at the end of today's lecture. I want to touch this topic. I don't want to over exceed the content of the lecture. So I can know that you are kind of following what's going on, right? Okay, so then, yeah, so this slide is a bit demanding. So for if stream and outstream classes, we have input outputs in and input outputs out automatically and respectively assumed. I think this is somehow clear what's going on here, and let's say we are going to have more considerations afterwards. Let's say, okay. All right. Then there is another example of Scanf of usage of, because you see, I want to point, I don't want the purpose of my course is, the purpose of this course is to mostly concentrate on C++. By the way, there's a very good webpage, c++.com. Please use this webpage very often. It's absolutely excellent. So you have very nicely given documentation. But let's say, in a sense, C++ is extended version of C or upgraded version of C. So some rudimentary examples of C, I want to include it, but somehow I put more attention in C++. So there is scanf function that is useful in, so it gathers input. So it collects input, right? Converting it into value. And then the syntax is, well, it is as it is pointed here, is scanf, and then there's a format string. You have it given here, and then there is address of variable. So this is a pointer, right? That's because you have ampersand you have it. This is stands for address of variable A, right? And then there are tons of options connected with formatting strings. So basically, maybe in a different way. Yeah, so you have fscanf. So there are options which you can use. So so you can have the option like decimal integer. Then you have octal integer. There are unsigned decimal integer. This is U. There is a string of characters. So you have a char. So you see this is. Then there is a floating. So this is string. This is pointer to a real value. So you have options E small, E big, F, G, small f and G, and big G. So this is floating point. Decimal number containing a decimal point, optionally preceded by plus or minus sign, and optionally followed by the E small or big E character and a decimal number. Two examples of valid entries are here, minus 732.103, and so this is in non-scientific, in a sense, mode, and this is second is a kind of scientific, like E stands. If you write it like this, 7.12 times 10 to the power 4. This is what does it says this, just to let you know. Yeah, there is so-called hexadecimal integer. I will show you this in very specific example, unsigned decimal integer, and also a single character reads the next character. So it does interpretation to a. So you have input-output operation that is somehow executed by a keyboard. So you need to tell the computer how to interpret it. So yeah, single character. So reads the next character. If a width different from 1, is specified where function reads with character and stores them in the successive locations of array passed and as argument. Not null character is appended at the end. Yeah, I'm not sure if to what extent this is, let's say, understandable. If you go to the original documentation, this will be a really nasty one. So in a sense, I try to sell it to you in most simplified way. That's why I'm not making this lecture to be very abstract. I prefer to evolve from simple form to more abstract form steadily. All right. So there's another way of printing things in C. So this is what you have here, shown here. There's a program in C. So you see, you can put comments in the first line. There are the comments, like here, right? And then you have standard input-output operation. So in the standard input-output operation, you have, there is a main. This is, of course, and return 0. This is standard case. And now, let's say, let us maybe at first concentrate on the output, but let's say, let us associate 3 ways of writing down the year 1977, right? So this year we want to write on the screen in a different ways. And one is with usage of decimals. And as you see, there is a proceeding with the blanks and proceeding with zeros. So you see, so you have the number. So decimals, and there are parameters which I have just mentioned before. DLD are the parameters, and there's another parameter is also here, and another parameter. Sorry for that. Another parameter is like that. So we can, yeah, we can come back and study these parameters. Okay, at the very end, I will show you some documentation. Unfortunately, it's a bit involving this this printf option. This is just writing down to the screen, and yeah. Yeah, so you can also write down the let's say p number by different ways. This is let's say given here. So you have written this. So just refer to the third line, the last third line of very end of execution. So you can write it 3.14. This is with certain precision, with 2 digits, right? This is most commonly seen. You can write it in a scientific mode, like, so in the first approximation is 3 times 10 to the power 0. So this is like this one, right? This is because of rounding. And then the third option is like scientific mode option. Sorry, this is like scientific option in greater detail. So what you have here is, yeah, so you have 3 types of formatting. It's quite, maybe I will just just move back. So one stands for float. Yeah, so this is floating point, decimal number containing a decimal point. So this is this floating, right? So you have it here. Second is small e. Small e is yeah. So this is e. So e to this is like 10 to the power. This is e. So this is of smaller. So first is of smaller precision, and big E is of bigger precision. So you have percentage sign and e. Well, so you see this is a bit tricky, but this is, so this tells you like, yeah, so this is how many digits before and after the dot, in a sense. So if 2 digits is 4.2 f. F is like, you see, is this option. I know this is a bit kind of horrific in the real usage, but that's how it is. So my obligation is just pass this message to you. I'm not going to pay too much attention to this comment, since everybody can use documentation somehow, but just to let you know that, you know, you can, yeah. So by the way, that's, if we go to the previous case, the third line is 10 decimals, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, so this 10 decimals is written here, you see. It is, this is this. There's options LD. You can play with that, but let's say I'm not going to digest it deeper. If somebody has such motives, please do it on your own, and then you can also let me know. All right. Yeah, so this is also, you see different bases. dx is O, let's say dx0 octal. So you have hexadecimal. Does anybody know what is hexadecimal? That's quite interesting to to point out. Yeah, so maybe I will have a small task for you guys. So I want you to convert. Okay, so guys, the computers are using binary representation, 0 or 1. So you can write every number as so you can write a number in binary representation, and then you can write a number in decimal representation. So decimal is based on the powers of 10, right? So we use digits from 0 to 9 plus 10 to the power of 0 or 1 or 2 and so on. This is decimal. Binary is 0 and 1, and we are using the power of 2, right? And hexadecimal is based on the power of 16. So it's so like digits are 0, 1, 2, 3 up to 9, 10, 11 is also a digit formally, 12, but 11. Then you have, after 9 you have A, B, C, D, E. So this is hexadecimal representation of a number. So let's say, yeah, so this will be a homework to write a program that converts a procedure from so the program will write it to will read from a file a number in a digital way, and we will write, so one text file has a digital number, in decimal number, let's say, and this has to be converted to hexadecimal. This is a homework. So you give it a number in a file, text file, and the program converts it to hexadecimal and gives you output in another file. That's what's supposed to be done. All right, I will move on a little bit further. So then there's another issue which you're supposed to know. This is about generating a random numbers. One of so this is standard input outputs, standard lib, and time. So this is system, takes time from a system with certain milliseconds of precision. So you have this declarations of two integer number, secrets, I guess, and then this is srand. Srand command is how to generate a, so it's turning on the random generator, and then so you activate this generator of random numbers, and then you have so you have secret. So this is division by modulo, right? Can you see this? Hello?
Yes, I can see. I can see.
So the idea is to generate. All right. So the idea is to generate a RAM integer value between 0 and rand max. Rand max has some value in you need to test it. What is rand max as well? You can print it on the screen, and then so this does generate. So this secret is a random number, and then you have this. Let's say this kind of do while loop, and that does prints you this yeah. So you have printing of the it will guess the number from 1 to 10, and scanf is what? What is scanf? We'll refer to. So this is like reading, gathers input. So this is reading, all right? Okay, 1 second. I need to charge my computer. All right. Okay. And yeah, so it covers your yeah. So it does collect the number from the keyboard, and then puts the number on the screen. That's also another way of puts is projection on the screen. So this is like C output, but in C. All right, and let's say how much time we have left already till when we have we're supposed to have a lecture. Hello?
Till 1, so we have 22 minutes left.
All right, so I will move on. All right, so just I want you to exercise, so then I will partly refer to your ability to do certain examples also in reference to c++.com web page or other web pages. Yeah, so then I just want to tell you a few words about pointers. So we are touching this subtle topic. Yeah, so yeah, so also please exercise in your home. Let's say, so one thing is conversion of let's say number based on the powers of 10. This is how we are using in everyday word, the hexadecimal representation, but I want you to write a code. And second would be maybe generate two random numbers and make plus and minus of them and generate it to output files. So maybe two types of homeworks. Then you use this srand command.
Can you write every homework at the end of the class?
Yeah, I will.
Because it's kind of
yeah. Sure. I think you know, this level of independence. So I would prefer if you send me the PDF. So if you send me PDF as a report result and could be packed code that is that I can run somehow, right? And maybe maybe it's better if you do it, those two things, if you do it, send them maybe to my alternative email account, because I might have unfortunately, I'm using this university stuff, and these guys are a little bit slow. They have old servers, so in that sense, I want to avoid, I want to avoid overloading of my accounts. So please write to kdvpomorski@gmail.com. Let's say maybe here as well. That's my another email account. This is not so much formal, but still I am using it. All right, so okay, just to, all right, so question is, can you see my screen, the pointer variable?
Yes.
Hello?
Yeah.
So yeah, so the thing is, we have a pointer and variable, and so pointer is address, but it's kind of necessary to recognize that yeah, so pointers, because if you have array of images, that every image takes 1 megabyte of data, of course it's quicker to refer by pointers than just by values. It's quite obvious, right? I mean, so pointers, one of the reasons pointers are used is because they are how to say, they can be very quick. However, there is always disadvantage. I mentioned to you during last lecture, there is disadvantage of using of assembler. It's very basic programming language. Its advantage is very quick, but the disadvantage is its complexity. So if simple problem is very complex to be encoded, that's brings some problems. So here, disadvantage of using of pointers concept is you can easily mess up in your memory, and that's one difficult part of C++ actually. All right, so that's a pointer, and yeah, so you have value 26, and there is address in memory. By the way, address in computer memory is usually done by hexadecimal representation. That's quite important to know. All right. I will now move to very explicit case. So in pointers, you have a data type which you have defined. Of course, the easiest part is integer type. That's open issue, how complex data types you might have, but of course, usually they have to be finite, right? That's how it is. So you have data type like integer, string, or anything else, or type defined by you. Then there you have pointer symbol. As you can see, there's a pointer symbol, and there's a just variable name, but this variable is a pointer. And so declaration of a pointer variable to hold the address of any integer type variable is int.space, and you see this like asterisk, like yeah. And then there is a name. So that's quite clear what's here, right? Then there's so this is a pointer variable to so the variable name of the pointer variable name is I_ptr. So this is pointer variable name, right? So this is pointer to integer, to another variable that has integer value. Then you can declare a pointer to a char. So like single pressing of the button is char space, as you see. And then there is a pointer to float fptr with such a name. And by the way, this link that is here, it turns out to be very useful. So I encourage you to go into that link afterwards. All right, then how to write a simple program that use the pointers. So this is input standard output library, as you can see. Then there is int main. This is standard return 0, right? And then we have two integer values. So one is this is like unsigned int. Treat this as int, let's say. This is space, and this is integer, the variable name, and this is already set to 65. So this is the value is 65. And then another line is a pointer to unsigned int, so type of variable, and this name is underlined PTR. And then there's a very crucial step. There's a very crucial step that is that. So initially, in the first line, you have declared and you have initialized integer in an unsigned integer type, and the value is 65. And there are some address in memory, and this address in memory was actually given by operating system. So compiler communicates with operating system whenever it compiles the program and whenever it executes the program. So the operating system is giving particular place in memory. So in a sense that, and this memory is unknown in at the very beginning to a compiler, and you can get this name of a place of address in memory for a particular variable. And how you're going to do it? Well, this is I underlined PTR is equal to this. You see this. This is how to extract address from a variable, ampersand like. So evar, this is name of variable. And then again, you have printf. This is like ancient command which I have mentioned to you. That's about usage of p. Again, so this is, you see, so address is, and let us check what is p. Unfortunately, this is a little bit. So p is, where is p? Oh, it's not specified here. Well, I have to, maybe also should, yeah, I mean, yeah, so let's say not yet mentioned. So this is, this is type of formatting, but this is actually hexadecimal. Why is that? Because it uses numbers and letters. A, B, C, D, E, F are letters. So this is hexadecimal representation is representation for addressing memory. All right, and then second line is value at address. So this is address, and then there is U. Let us find out what is U. Unsigned decimal integer. So the second one is decimal, which is powers of 10. That's quite important. All right. Yeah. So we have it. So we have it here. Yeah. So, and this is like end of line /n. This is like end of line. So, yeah. So at this line is presenting only the address of variable integer, that is evar, and second line is presenting you both. This is printing first value and this is now is a very important part also. So this one is address of value. This is value of pointer. So this is just address in memory. Also, we need to study the memory structure to tell more about pointers, but let's say this is address of memory. And this is very nice operator. So this operator is an asterisk pointer. So it's actually value of variable to which pointer is pointing. So this pointer is pointing to this address of this variable. So this is supposed to give us 65, and actually it does. It does. See? Well, look, this is a very tricky way of writing. Value at address. This is printf. So here is like one value, because it is in between, and there is like another value. So this printf is bit comment is bit kind of tricky. You need to practice to use it. Yeah, so this is how things are. Yeah, and so far, is it somehow understandable what I'm saying? Hello? Hello?
Yeah.
Yes, yes.
All right. Because we start to approach bit kind of challenging, part. Now, I will give you another example of usage of pointers, but without comment printf. That's a little bit, demanding as it is here. All these nice options with percentage that are embedded inside. So we are using C output. So printf is a C, scanf, and printf is coming from C, and this C output is definitely C++. So the value of variable is, so we are first, this is like end of line, as you see, this one. So we project the value of int, the first one, this I. Then the memory address. So we can project memory address even without declaration of memory address. Without declaration of pointer with ampersand operator. There's ampersand operator, as you can see. So another line projects the address of int. So this prints the memory address in a hexadecimal format. By the way, hexadecimal format is a format that is typical for addressing memory. It's a kind of standard. Well, that's how it is. And then there is a C output, the value of variable. And now you see that's quite tricky. So to exercise this comment, which I have just mentioned, we have value of variable I using star operator. So you see here, if I write it ampersand I, this is a pointer, which is a just address in memory. This in hexadecimal representations of a number in terms of powers of from 0 to 16. And then when I put this asterisk, this sign in the front, this means that I want to have value of variable to which this one points. So this together will be a value. This will be one second. This will be a value. And then there's end of line. It's like here. So you have all this even more details over here in this link, which is also given here. So I'm just projecting you this concept, how to use it, because we have to go with a small steps, not to because we cannot, the studying of technical things and mathematical things is about increase steadily the level of difficulty. How it is. This is how it is. All right. And then there's another example which is very nice, but it's also a little bit. This has to be later improved. This is about adding two numbers, but using only pointer concept. So what code I have, I will briefly describe you. So I have input output stream. This is the first one, that's standard, right? Using namespace is standard. Maybe there will be one lecture that describes these things in greater detail. Then I declare a function, but this function is a very special one. I have inputs that operate on the pointers. That's quite important. So inputs points to the pointers, and then the output is as you see is a value coming from the pointer. So input is a value coming from the pointer. You will see this so this is function declaration. So, and actually the function by itself is given here, see? So you can declare a function without writing a body of a function. And now you write a body of the function, because this body of this function is actually, this one. This is a body of a function. So how things are. Okay, let me do step by step. So we have declared, you see, and created a variable result that is a pointer to integer, and then this result kind of variable is okay. So this itself, okay, so and then we add 2 pointers. So to pointer variables points to a variables with a certain value, and we added those 2 values. So of course there's a pointer to an integer. So this is how we add it. So this is the result. So that's how we write it. We need to exercise it, and later we project the result on this guy, and that's how the sum. This is how this. So the value of the sum is int this asterisk. So this is the result. So you need to exercise this, and then how it works in practice. Well, int p equal 10, q set to 20. That's initial values of integers. Then there is a sum of 2. So you see sum, but then the argument are pointers. So this is pointer to p and pointer to q. This is ampersand, and the result is a pointer, is a value pointed by pointer in a way. Yeah, and then it's projected on the screen. So you need to run this program step by step to see exactly how things are done. I'm trying to familiarize you with this concept. This will take some time to digest things bit by bit, right? All right, and then already mentioned this. This is CMAF. This is already our colleague has pointed this out. This CMAF library, it allows square root of, this is square root of 64 can be computed. 8 times 8 is 64, so square root of 64 is 8 actually. So 8 will be projected on C output. So that on the screen, round is evaluation of so bringing real value to integer value to the closest integer value in a sense, right? And there's a logarithm. You can have, but then you can use this mathematical operations only when you include CMAF library in your code. Okay, very last of the last, just to, because since we have already, it's actually its last slide. So we there is additional thing than just structure of data. There's a class. It's a little bit hard to say because you see, so you interlink data and types of operations you can do on the data. That's a class. And also classes has some abstract levels in C++. So here I am just pointing you how to create a class. Yeah, so next, not this one, but next week, we are going to create a class that allows for operations on quaternions. Just something new that is unknown to you because you can exercise yourself. But anyway, here is just the most rudimentary example of the class. So you have main code as given here. So that's absolutely nothing special. This return is something obvious. Then there is a create object that is a certain class. So it's a combination data and procedures or functions on these procedures, how to deal with certain operations. So this is my class, is a type of class. Yeah, this is at the very beginning. And then this is object, my object. And calling this object, so in a sense, calling this object is nothing else as initializing this object is my object. So this is this name. This is my method. That's so you activated the existence of this object here, but then you want to use a procedure that is inside this object. This is my method. Call the method. And then how is the class? So class is combination of data and procedures. Class, my class, there is it's public. This part is seen publicly. So here one method is defined. This is method, my method. It returns void, so there is no return here. This is like procedure that gives nothing, but only plays the name on the screen. This is hello world. This is how it is. All right. So guys, that's it. So this is, you see, contrary to last time, I tried to be more technical, but obviously I'm not that deeply technical since, yeah. So do you have any questions? So you asked me to write down the homework to you, right?